Hello and welcome to my first lesson on matrices and transformation. In this lesson, I'm going to have an introduction to the topic and tackle the first objective of the day, which will be finding the matrix of transformation. In subsequent lessons, I'll be tackling the following. The second one will be single matrix for successive transformations, inverse of a transformation, area scale factor and determinant of matrix, shear stretch and isomerism. So I'm going to have several lessons that will be following after this, probably the next one coming after 2 or 3 days. And so we need to begin with the first one. We begin with finding matrix of transformation. But maybe I should say this. Before we start that, we will need to look at some, let me call them introductions to the whole topic, in which case we're going to look at transformations and another aspect of matrices. And let's begin with some transformations for definitions purpose. Now, transformations can be a reflection. A transformation can also be a rotation or an enlargement or a translation. These ones, it's supposed they should have been tackled before this particular level, but towards the end of this series of lessons, we will tackle shear and stretch. And so at this point, I'm not going to say much about transformations, but we say some few things about matrix multiplication, just as an introduction to what matrices are, and probably defining the whole idea of matrices a lot more. So first of all, a matrix is a rectangular arrangement of elements, normally enclosed in brackets. They can be big or so, or that's a big number of elements or a small number of elements. It can even be a single one. In this case, we have 4 elements, which is 9, 4, 6, 2. And the 9 and 4 are arranged in a row the same way as 6 and 2. And 9 and 6 are arranged in a column the same way as 4 and 2. And therefore we say that one forms the first row, the second one there forms the second row. And that means also that this one here is the first column and the next one there is the second column. And that means that every point or every element in this matrix is uniquely placed, such that no 2 elements are placed in the same place. Now, at this point, I want to mention some 3 points which I find very necessary for us to understand properly, so that we can use the concept to operate questions that have to do with transformations and their relationship with matrices. And therefore, the first thing I want to say is this: that whenever we are multiplying 2 matrices, this matrix being multiplied with another one, we normally multiply a row in the first matrix with a column in the second matrix. We'll get to that in actual example. The second point I want to say is this: that if R first times C first means the order of the first matrix that you're multiplying with another matrix whose order is R second times C second, then the resulting matrix will be of order R first times C second. To explain what that means is, if this forms the order of the first matrix and this is the order of the second matrix, they are multiplied together in this particular order, then the resulting matrix will be of order R1, R first times C second. That means the number we had here will be the number of rows of the resulting matrix, and the number we had here will be the number of columns in the resulting matrix. Maybe to draw that close to, maybe again or in a different way, I use this example. If R3 by C2 is the order of the first matrix, that one is multiplied by R2 by C1, then the resulting matrix will be of R3 by C1. Now, if this is the first matrix, that is a 3 by 2 matrix, that means 3 rows with 2 columns, and the next matrix is a 2 by 1, that is 2 rows and 1 column, then the resulting matrix will simply be a 3 by 1 matrix. I hope that explains the concept better. The third point, about compatibility. We normally say that if in all cases of these 2 matrices that you're multiplying here, the matrices are only compatible, or I would say possible to multiply, if the number of columns in the first equals number of rows in the second. That's why I've written C first, to mean the columns in the first should be equal to R second, which means number of rows in the second. And that means that, like in this case here, this number must be the same as this, so that it's possible for us to multiply the matrices, sorry. Otherwise they are not compatible, and so it's not possible to multiply. As we go ahead, I want to try an example of matrix multiplication. So we have 9462 multiplied by this matrix here. Clearly the 9462 is a 2 by 2 matrix, and the other matrix is a 2 by 4 matrix. So we know a few things. One, these two matrices are compatible because the number of columns in the first equals number of rows in the second. Again, the resulting matrix will be a 2 by 4 matrix because of the concept I just explained in the second point here. So as we go ahead with multiplication, I would say the following. Number one, since we multiply a row by a column, that's according to the first point, we'll therefore multiply 9 by 1, then we add 4 by 3. That gives us the first element in the first row. The second element in the same row will be 9 by 4, then 4 by 7. You add the 2. The third element will be 9 times 2 plus 4 by 1. The last element in that row will be 9 by 0 and 4 by 8. Then below there we will have another row. The first element in that row will be 6 by 1 plus 2 by 3. The next one will be 6 by 4 plus 2 by 7. The next one will be 6 by 2 and 2 by 1. And again 6 by 0 and 2 by 8. And therefore this is what we have there. Please pause the video so that you can be able to follow that a lot better. Again, please simplify these ones following the rules of Bodmer's. You do the multiplication and then you simplify by adding, and therefore the matrix will be that one there. And I hope that refreshes your concept about what matrices are and the concept about the multiplication, and that will be needed as we continue with the next few lessons in this series. So we go to the next bit. Find the matrix of transformation. So in this case, I want us to look at two possible questions. The first one, what transformation does the matrix represent? In this case, we are talking about a situation where we are given a question where we have a matrix that has been given, and so we wonder, what does that matrix represent? What does it do to a given object? Does it reflect? Does it rotate, enlarge, translate? Is it a shear or is it a stretch? The next question we'll be answering is, what matrix results to a given transformation? In this case, we are given an object and its image. So we're wondering, do we have a particular matrix that defines how the image was transformed? How the object was transformed to get us the image? So those are the two questions we'll be answering as we go ahead. And at this point, I want us to do the first one in an example, and then we'll do the next one in another example. So the first one, we have a question. Describe the transformation represented by a matrix M on the triangle ABC, and the matrix is 0, 1, negative 1, 0. So we continue. Solution. The first thing we'll need to look for is determining the coordinates of the image. Remember, here we are given a matrix. We want to know what transformation does it have on the given object. What transformation does it have on the given object? Therefore, we must have the object and its image. So this point, we look for the image, since we already have the object. The image is gotten by pre-multiplying the matrix with the object. So I have 0, 1, negative 1, 0. That's the matrix that was given, pre-multiplying the coordinates of A, B, C. Now A, the coordinates was 6, 5. The B, the coordinates was 2, 1. And C, the coordinates was 6, 1. So these are the values there. And of course, I have them for you there. So what do we get when you multiply? Of course, we get these figures here, and that's the coordinates of A prime, B prime, and C prime. So 0 times 6 plus negative 1 times 5 gives us this. 1 times 6 plus 0 times 5 gives us this. So we have the coordinates, the xy coordinates for A prime. The same case also get for B prime and C prime. Now in this case, we have the object, which are these coordinates here. We have the image. The question is what transformation happened there now, which would be, of course, describing the matrix M. At this point, we're going to plot the object and the image, and I have done that for you. So we have what I have there. The triangle ABC is this one here. The point is 6, 5. and 2161, and the coordinates of the image are given also. This is negative 5 6, then this point here is negative 1 2, and this point here is negative 1 6. So the question would be, what transformation happened to move or change ABC to A prime B prime C prime? Well, clearly this looks like a rotation about the origin, and therefore we'll say it's a positive quarter turn about the origin. It's a positive quarter turn about the origin, and yeah, it's assumed that this point you should be able to know what rotation is all about. You can always refer to other lessons that I did previous to this. And so we would say it's a positive 90 degrees turn about 0 0. That's the origin, and that answers the question. What transformation describes the matrix 0 1 negative 1 0? For any object we have, not even the ABC, it doesn't matter what type of object we have, all objects subjected to this transformation would be rotated about the origin through a positive 90 degrees turn. And that's that simple. Let's turn to the next part. What matrix results to a given transformation in the next example? So before us, we're given a question. We're told the values of an object P, Q, R, S, T, U, V, W are P prime, Q prime, R prime, S prime, T prime, U prime, V prime, and W prime. Determine the matrix. We are not given the matrix here, but you're told determine the matrix and the transformation thereof. So we progress. The first thing, we're going to let the matrix that we don't know, we are going to let that matrix M be A, B, C, D. Okay? And since we are looking for the values of A, B, C, D, since that ultimately will be the matrix M, we are going to do a similar thing to what we have done in the previous case, in the previous example, though with a slight change here. And this is it. We pre-multiply the unknown matrix, that is A, B, C, D, with any two coordinates of any of the points that given. We have P, Q, R, S. You can pick any two, but I've picked the first two. P, 1, negative 1, and Q, negative 1, negative 2. And that should be equal to the coordinates of P prime, Q prime, which were negative 1, negative 1, which is that one there, and again negative 1, negative 2, which is that one there. Therefore, you should look at it this way. These two here are the coordinates of P and Q, that is P 1, negative 1, Q 1, negative 2, and these are coordinates of P prime, Q prime, which is negative 1, negative 1, and negative 1, negative 2. Therefore, pre-multiplying the matrix should be equal to this. Okay? And so below there, we have the illustration drawn for you that this one, that is after multiplying A, B, C, D with 1, 1, negative 2, we get this matrix should be equal to this matrix, which was what we had at the beginning there. So we are just saying that what we have before the equal sign is the same as after the equal sign. And therefore, since the two matrices are the same, we would be saying A minus B should be equal to negative 1. A minus 2B should be equal to negative 1 again. C minus D should be equal to negative 1. C minus 2D must be equal to negative 2. And therefore, we have this kind of illustration. A minus B is equal to negative 1. A minus 2B is equal to negative 1. And C minus D is equal to negative 1. And again, C minus 2D is equal to negative 2. At this point, you're supposed to solve the way you want to solve it. I really don't have to delve into that. But you can always use simultaneous methods. You can do simple elimination. And having eliminated, I did get the values of A to be negative 1, B is 0, C is 0, and D is 1. Now we have the values of A, B, C, D, which is negative 1, 0, 0, 1. That tells us the matrix M that we wanted is negative 1, 0, 0, 1. And so we have answered the first part of the question. Determine the matrix that transforms P, Q, R, S, T, U, V, W to P prime, Q prime, R prime, S prime, T prime, U prime, V prime, W prime. That matrix is this one here. Now, an examiner could be wondering, so what sort of transformation is that? And that's the part I want to answer now. Although, I should say that this part of my lesson, I was really dedicating to finding the matrix, which we have kind of finished. We actually finished. I just thought maybe an examiner would be wondering, are you able to identify the transformation? And that's what I want to show you. Now, to identify the type of transformation there is, I plotted the two the two, the PQRSTU VW and its object. That's the object and its image, and that's what we have there. It's some sort of a letter T. This is the object, and this is the image. And so someone would be wondering, what is the transformation? How is this T, how is it transformed to get to this other one? This looks like a simple reflection along the y-axis, such that this falls on here according to the rules of reflection. And you know, reflections are normally defined by a mirror line. Sorry. Therefore, clearly, what we have on the screen there is a transformation, which is a reflection on the line x is equal to 0, which is the y-axis. And therefore, that is the answer there. We have determined the matrix. It is negative 1, 0, 0, 1. We have also found out the transformation. It is a reflection on the line x is equal to 0. And that brings us to the end of the lesson. But as I tie up these things together, this happens to be the first objective of my series of lessons. And therefore, I want to say this. Anytime you're told to describe the transformation, like in the previous example, ensure that you obey the rules of saying reflection, rotation, enlargement, or translation. For example, if it is a reflection, you must state the mirror line. If it's a rotation, state the center of enlargement, the center of rotation, and angle of rotation. If it's an enlargement, you need to state the scale factor and the center of enlargement. If it's a translation, you should be able to mention the translation vector in all of those cases. If it's a matrix that you're looking for, you must give, of course, in the form of a 2x2 matrix, as I have shown there. Having said that, please look out for my next lesson, which will be tackling the second and probably the third objective in the series of lessons. Thank you.